Okay, so here are the examples that are on your solubility worksheet. Okay, so once you've done those, watch this and you can get the answers. Okay, so again, we know that our metals are going to switch spots here. So barium is going to go with chromate, potassium is going to go with chlorine. So potassium again is a +1 here, chlorine is a -1, so we end up with KCl over here. And then our barium goes with our chromate. Our chromate is CrO4, that's a -2, and barium is a +2. So one of each one of those, or that one. Okay, so now that we've got our two products, we have to decide, are they soluble or not? So we have to look at our rules. Excuse me. Rule 1, okay, alkali metals and their ions are soluble. So that means this one's going to be soluble. It also goes with rule 4 that the halides, which is chlorine, is soluble unless it's with silver, mercury, or lead, and it's not. So we know that this is aqueous and it's soluble. Okay. Next one is chromate. We have to go down to rule number 7 down here. Chromate ion, the only exception is if it's with an alkali metal. Barium is not an alkali metal, so it says down here these are not soluble in water. So this is going to be a solid, and it forms a precipitate. Okay. Next one, strontium and lithium are going to switch spots. Lithium is going to go with acetate. Lithium is +1. Acetate is -1. Does not matter which order you do these in, you guys, just so you do both of them, okay? So we end up with LiC2H3O2. And then strontium is a +2. It's going to go with hydroxide, which is a -1. So SrOH in parentheses 2. Okay, so those are your formulas. Now we have to look at our rules. If we look, let's see, let's find. We've got lithium and acetate. So acetate is rule number 2 here. Anything with acetate is going to be soluble. So that's going to be an aqueous. And then our hydroxide rule is down here at the bottom. Hydroxide is not soluble except for if it's with calcium, strontium, and barium. In this case it's with strontium, so this one is also soluble. So this would be an example where you would not get a precipitate. Okay. Next, our zinc and sodium are switching spots. So sodium is +1, sulfate is -2, so we get Na2SO4. And then our zinc, which is +2, is going to go with our carbonate, which is -2. So ZnCO3. Those are our two formulas here. Now we have to decide if they're soluble or not. Sulfate rule is number 5. Okay, rule number 5. Sulfate is soluble except for if it's with strontium, barium, or lead. It's not with any of those, so this is going to be aqueous, meaning it's dissolved in water. And then we have zinc and carbonate. Our carbonate rule is number 6. It's not soluble except for if it's with the alkali metals or ammonia. And in this case, zinc is not an alkali metal, so this would form a solid or a precipitate. Last one here, number 4. Manganese and potassium switching spots. So potassium is +1. Nitrate is -1. So we get KNO3. And again, you can write this first or second, it does not matter. Potassium then, we already did potassium, sorry, manganese, which is, this is a +2 because it's with nitrate, and we needed 2 nitrates, so we know that's a +2 charge, and then that goes with hydroxide, which is -1, so we have MnOH in parentheses 2. Now to check our solubility, if we look at nitrate, nitrate is always soluble, rule number 3, so we have aqueous here. Hydroxide rule, again, is all the way down at number 10. It's not soluble except for if it's with calcium, strontium, barium, or anything from rule 1, which is alkali metals or ammonia. It is not the case, so this one is also going to be a solid. Okay, so those are your examples from that. So go ahead and do your practice problems to continue to practice with double replacement reactions.